All right. Hi, everybody. Can you see me? Awesome. Okay. Okay, great. So you guys have posed some questions already, which is great. I'm going to start off by just introducing myself, talking about some updates to AP, and we'll go from there. Okay. So some of you may have heard what's still on the AP exam, and some of you may have not heard much so far. So I'm just going to go over that really quickly. Let me go back to my PowerPoint and share that with you guys. Okay. So this is a Q&A session. I do have things prepared if you don't have questions. I do want to say right now, you guys have asked a lot of great questions. I'm not sure we'll be able to get to them all today. And I'm not sure if I'll be able to answer every question you have right now. But if I can't answer it right now, I will definitely find a time to get back to you. I'll post it with the stream so that you can come back and look and hopefully your question is answered. Okay, so we're going to start by looking at what changes have been made so far. Okay. So on the exam, they've made a few updates to account for students having to take it at home. One of those updates is that there's now 2 test dates. One's going to be a little bit earlier in the year for students who aren't considering continuing to study it. And then there's going to be one later in the year, around the time when you were supposed to take it. It's going to be 45 minutes. It's going to be online. And we haven't been told about the layout in terms of multiple choice or free response question, but we know we're supposed to know by April 3rd. AP did put to the teachers, I'm sure to you guys too, that they have algorithms, things they use to make the questions. They've done online testing at home before. They're confident that this will still test your abilities against your peers. In AP Calc AB, it'll be covering units 1 through 7, and unit 8 is dropped. Okay, so in some of the questions, we did have questions about the disc and washer method and questions about cross sections, which is fine. We can definitely still go over those, but I'll probably save those until last since they're no longer on the test. Okay, so, and then let's look at, I'm going to share another screen with you right now for a second so you guys can see what is on the BC test if you're in AP Calc BC. Okay, so let's look at this. All right, so if you look at here, the column on the left is what units are going to be on the test, and the column on the right are units that are not going to be on the test. So for BC Calculus, if you're in BC, unit 9 and 10 are taken off except for 10.2, 5, 7, 8, and 11. Okay, so let me make that a little bit bigger for you again. So take a look at the class you're in, A, B, or BC. So BC 9, all of polar and parametric is taken off of it. But for unit 10, you still have to know some of the sections. And if we want to see what that includes, we can look over at those sections in a minute. Okay, are there any more questions about the setup of the test or the changes that are happening? I'm looking up the BC, what those sections are right now, so I can tell you BC students exactly what it is that's been added from unit 10, and so you know what you don't have to know too. And then we'll go from there. So if we go to BC. All right, and we look at unit 10. So the sections that are included are units 2, 5, 7, 8, and 11. So 2 is geometric series, 5 is harmonic series and P series, 7 is alternating series test for convergence, 8 is ratio test for convergence, and 11 is finding Taylor polynomial approximations of functions. Okay, so today is a Q&A. I'm not exactly going to be reteaching everything, but more answering questions as we go. So I'm going to take a look at the questions here. Okay, great. Okay, so I'm going to start with this question. Will our abilities going into BC be hindered, or will the course be harder because we have Unit 8 don't have Unit 8 under our belt? Okay, so are you a student that's in AB and is looking to go to BC next year? Okay, so it depends on the course structure. When I teach BC Calculus, after students that have taught AB, we go over every section that was in AB beforehand anyway. So this would just mean the time you learn Unit 8, it will be the first time you're learning it. So it may be a little bit more difficult. But right now, on Fiveable and on other websites, you can still try and learn Unit 8, even if it's after the test, just to make sure you're still on track with where you want to be when you get to BC. That's what I would suggest. And then there's also courses that you take either AB or BC. And in that case, then you would have all of Unit 8 when you took BC Calc. But yes, most of the time you're going to go over it again. Having it twice is probably better than having it once, as with any kind of learning, but you should still be able to do it. Okay. For, I think it's Raya or Ria, I'm not sure. If they give you a series that you could do better with a different series that you've taken out, can we still use it? And would they give credit for it, or should we stick to the ones they've given us? So that's a good question that I actually don't know the answer to. I will take that to AP and to the teachers and see if anyone knows the answer to that. The thing about that is, unless they tell you exactly how to solve it, you should be able to use anything you want. So for example, did any of you learn how to do, if you've learned Unit 8 already, did you learn cylindrical shells? It's another method besides discs and washers. Yes. So cylindrical shells is an accepted method for finding the volume of something rotated around an axis, but the AP doesn't specifically test on it. So I would say, based on how AP assesses that if if you have a different series that you know better and can use better than one they've kept on the test, then you should still be able to use it, unless it specifically tells you to use a certain type of test or a certain type of series. Mm-hmm. Okay. All right. So related rates, we've got just a general question about related rates. So I'm going to look for a question that uses some related rates, and we will go from there. Okay. So I'm going to go back to the 2017, 2018 AP, AB free response questions. And a lot of those free response questions are really good for this review because a lot of them have multiple topics within them. So let's see, is there another question? Okay, great. Okay. Just give me 1 minute. While you're waiting for me to go over this, what I'm going to do is share my PowerPoint again and go over how to solve related rates in general. Okay, so if we go over here. Okay, next slide. Okay, related rates. So take a minute, look at that process, see if you have anything you would add that will help the group, anything that would change, and I'll get a question ready for you. Okay. Yeah, sorry, I didn't realize I had made me half the page, but is this good? It's bigger now? Is it still too small? Okay, great. Okay, so when you're looking at related rates, the first thing you want to start with is drawing a picture if you don't know where else to start. You won't always have to draw a picture, but if you really don't know where to go, a picture is probably the best place to go. And then the next thing you need to do is figure out what you know, assign variables to it so that you know exactly what you're working with. And that's going to help you relate the derivatives and the rates to the actual values of the functions. And yeah, so for that example, if you label the ladder C, the rate the ladder's changing would be dc dt. So you want to make sure you're being consistent with your labeling. Then you want to find an equation that relates what you're looking for. Sometimes they'll give you that equation. Other times they'll give you a shape like a triangle or a rectangle, and you have to know all of those formulas from geometry. So area of a triangle, area of a rectangle, a circle, a semicircle, all of those are very helpful. And then if there's any variable that you don't need to find the derivative of, and you don't have the derivative of it already, if you have the value of it, you should plug it in right away. If you don't have the value, or if you have the value, but you're supposed to be looking for it, don't plug it in, because what happens is that ends up becoming 0 when you take the derivative. And we'll look at that a little closer in a minute. And then plug in what you know and solve for what you don't. And that's the nice algebra part of that. So what I'm going to do is share a problem with you. This is 2018 AP Calc problem 4. We're going to do parts A and D of this problem. Okay, can everyone see the screen? So we've got a table. We've got a height of a tree at time t is given by the function, the twice differentiable function h, where h of t is measured in meters and t is measured in years. Selected values of h of t are given in the table above. Okay, so we've got values of h of t. And this is a free response question that if you're looking to try anything and you want to try this whole problem, feel free to. I'm going to go over parts A and D in order to review some things from the first half of the course, mainly derivatives and related rates. Okay, so part A, use the data in the table to estimate h prime of 6, and then using correct units, interpret the meaning of h prime of 6 in the context of this problem. Okay, let's see if I can fix that for you guys. Okay. I think this is as big as I can make it. I'll make sure to read it to you. I'm sorry if it's a little blurry. I can work on that for next time. Let's see. Try one more thing. Can you see it any better now? Okay, still kind of blurry. Okay, well, I was going to go through and write the answers down with you. Why don't we take a look at I'll read it to you and tell me, even if it's a little bit blurry, I can work on that for next time, but I want to make sure that I can get the information to you guys. I can zoom in to here. Better? Might still be a little bit blurry, but you should be able to see. Not better? Can you read it? Okay, let me just get the question up separately then. Okay, can you see this better? This should be better because this is directly from the internet. I don't think I can make it any clearer than this. Okay. Awesome. Okay, well, I can't write on this, so we'll start with talking about the problem, and then if I need to move to writing, then we'll switch back over and we'll work on it from there. Okay, so let's start at part A. We've got a table, and it's talking about the height of a tree moving, and we know it's twice differentiable. And then it says use the data in the table to estimate h prime of 6, and then using correct units, interpret the meaning of h prime of 6 in the context of the problem. So h prime of 6, how do we find that? Feel free to write your answers in the chat. Even if you write the steps out, that would be great so we can see exactly what you did. Good. Rate of change over 5 to 7. So all we're given is a table. We can't find the exact derivative of h, so we can't, we just have to estimate. And that's what it says. It says use the table to estimate, okay? So if we look, we have 5 and 7. 6 is right in between those. So if we can find the rate of change from over the interval 5 to 7, then we can find h prime of 6, or at least an estimate of it. 11 minus 6 over 7 minus 5 is 5 over 2. Great. Awesome. So that is exactly what you want to do with this problem. 5 over 2 is correct. But now we need to make sure we're using units. Okay. It says using correct units and interpreting the meaning. So 5 over 2 what? It is going to be 5 over 2 meters per year. 5 over 2 meters per year is correct. So good job with that. Okay, and then what does that mean in the context of the problem? What is 5 over 2 meters per year? Remember, on a free response question, it's better to write more than less. You don't know exactly how the points are distributed when you first see it. So the more you write, the more descriptive you get, the better that can be for you. Okay, good. Good, yeah. So after 6 years, the rate of change of the height of the tree is 5 over 2 meters per year. That's great. Okay, great job. All right, let's scroll down. Actually, are there any questions on part A or how we found part A or described it? Okay. Well, let's take a look then at, is there a name for that process? That's just rate of change, average rate of change. If you're given a slope or if you're given a table and they're asking you to find a derivative, you're going to need to use the slope, which is just the average rate of change. Any other questions? Okay, let's look at part D. So part D is where related rates comes in. Well, let's try to have the table in there still. Okay. Yeah, so the answer to part A was 5 over 2 meters per year. and that stood for the rate of change of the height of the tree after 6 years. That's how to interpret the meaning of it. You're welcome. Okay, so part D, the height of the tree in meters can also be modeled by this function g, 100x divided by 1 plus x, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. According to the model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? Okay, that's a lot of information it's asking you. So this is a related rate. It gives you a lot of information, and you have to figure out how can you use that information to the best of your ability. I know it's going to be blurry, but I'm going to go over to my writing screen for this one so that you can see what processes I'll be going through. Okay, we'll move that over to the side, and I'll just write down exactly what we need over here. I'll make this bigger. Okay, so we're told that g of x is 100x over 1 plus x. And we're told that x is the diameter of the base. Okay, and then it tells us the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. What does that mean? Can we give that a name that's other than diameter of the base is increasing at a rate? So we've got a rate. We know what the rate is talking about. Good, awesome, dx dt. So dx, because it's the diameter, the base is x, so we're using dx, and we're doing that with respect to time. Per year, meters per year. So we want to use dx over dt. Okay, so we've got dx over dt, and then it asks us, what is the rate of change of the height of the tree with respect to time at the time when the tree is 50 meters tall? Okay, so what do we want to do with that? We want to find the rate of change of the height of the tree. So what are we looking for? Good, awesome, right? dg dt is exactly what we're looking for. So we have g of x. We have g of x here. And we want to find dg dt. Okay, and we have dx dt. It's told us what dx dt is. So what can we use? What information do we have that we can use to solve this problem? What do we need? This is where the title, related rates, comes in handy. So dx dt is 0.03. We definitely need that. We need a formula. Great, Perla, yep. The function g of x. Good, which we have. We have it right here. The function g of x, and we know d is 50. D, in this case, though, stands for x, the diameter. Okay, so we know that x, we're doing this when x is 50. Okay, so if we know that g equals 100x over 1 plus x, sorry, this is g of x, how can we find dg dt? What should we do with this equation? How can it help us? Take the derivative. take the derivative of both sides. So this is going to become dg dt equals, and now what do we need to remember? Yes, quotient rule. Good job. Okay, so this, did you guys learn quotient rules using U's or using U's and V's or F's and G's? We've learned it all different ways. I'll write down the formula on the side. So we've got, let's say this is f of x and this is g of x. Okay, so we've got g of x times f prime of x minus f of x times g prime of x over g of x squared. Yes? Do we agree? I also learned the low D high, so I was kind of doing that in my head as we were doing that. But good. So we've got, this is the equation we've got. This is quotient rule. Make sure you've got it memorized. That will definitely be on the test. So we need to find f prime of x and g prime of x. So f prime of x is going to be what? Good. So I want to remind you with one thing. We're taking the derivative with respect to t. So when we take the derivative of this, it's going to be 100 dx dt. Yes? Does that look familiar? It's kind of like implicit differentiation, where since there's a different variable on the bottom, you've got to add in that extra step. It's kind of chain rule here, okay? And then g prime of x is going to be, well, the derivative of 1 is just 0, plus the derivative of x is going to be dx dt. Good? Good so far? Okay, great. So let's keep going with this. So we know that this is dg over dt, and it equals low 1 plus x, d high, which is f prime of x. So that's going to be 100 dx dt minus high 100x, derivative of low, which is just dx dt on its own, over 1 plus x squared. Okay. So I'm just moving us up so we have more room here. Okay. So now we've got dg dt here, and we know dx dt, which is great. We've got that. But there's also x in here. And do we know x? If we're solving for dg dt, oops, sorry, put this back on here. If we're solving for dg dt, we need to know what x is, and we need to know what dx dt is so that we can solve properly. Okay, so actually x is not 50, and let me get you back to the problem. It's the height of the tree, the time when the tree is 50 meters tall. So 50 is our height. Okay. How can we use that to find x? Well, if we know g of x, yeah, exactly. If we know g of x is 100x over 1 plus x, that means g of x is going to be 50. Okay, and now we solve, so we multiply by 1 plus x. So we get 100x equals 50 plus 50x. Subtract 50x. 50 equals 50x. Well, x must be 1. Okay, so now we've found x. X is 1. We know dx dt is 0.03, as you guys have pointed out before. And now we've got all the information we need to plug in. So the place where I'm sure a lot of students had trouble during the exam was plugging in x equals 50. Okay, and that's kind of how AP is testing to make sure you're paying attention to the problem and what you have. So make sure when you first get all of your variables, you're writing down exactly what they stand for so that you're not accidentally plugging in something different for what it should be. Okay, so let's just plug and chug here. 1 plus 1, 100 times 0.03 minus 100 times 1 times 0.03 over 1 plus 1 squared. Okay. All right. I also got 3 over 4. Okay. Yes, 3 over 4 is good. So let's, if you do out this math, you end up with 2. And this is not a calculator section. So now, again, I don't want to say something that is going to change based on the AP test. On the original AP test, the way it was shown, you could leave dg dt like this. Okay, as long as you have plugged in everything, you don't need to simplify. And if the AP readers, what they'll do is they'll do out your math and make sure they would get the right answer doing out your math. And as long as you have it right in that form, you don't need to keep doing it. I don't know. I don't think that will change for this test, but especially because it's computerized, there's probably a chance that something's going to be a little bit different. So something to watch out for. We'll be giving you updates as we know, but April 3rd is the next big day to know those things. So 100 times 0.03, we just get 3 there, minus 3 over 2 squared, which is 4. So we get 6 minus 3 over 4, 3 over 4. And again, we don't want to forget, in terms of calculator, I don't know if there's going to be a calculator versus non-calculator section. That's something that AP, really, they're going to have to tell us on April 3rd. Sounds like there'll be more information there. Yeah. Okay, so 3 over 4 what, though? Because if we don't put units, we're probably not going to get full credit for this problem. Okay, I know you guys can't really see the problem, so maybe I should go back. It's 3 over 4. We're finding dg dt. So yes, meters per year. And just to make sure we have practice with this, what does that 3 over 4 stand for in this problem? If we were finding dg dt, what does that stand for? In the context of the problem, what did the function g of x stand for? Yes, rate of change of the height. Good. There you go. So that is the rate at which the height is growing when x is 1. So when the diameter of the base of the tree is 1 and when the tree is 50 feet tall. Okay. Awesome. Okay, good. Any other questions on related rates that I didn't answer that you wish I had gone over? I'm going to take a look at the other questions. You want to do parts B and C? We can do that if you want. Let's see. Okay, can I erase all of this that I've done? Okay, I'm going to erase. Or actually, I'll just move it down. And I'll take the problem. Okay. Let's actually, these look like ones I can share the other screen with, so let's go back. Hi, everyone. Good to see you again. Okay, let's go back here. Okay. So let's talk about B, because I think we can do that one without having to go into the whiteboard. So explain why there must be at least one time t for 2 to 10 such that h prime of t equals 2. Okay, explain. So we're going to need to use some words here. What do you guys think so far? Oh, sorry. Yes, I can make it bigger. Okay, so why must there be at least one time t that h prime of t is 2? So you're on the right track when you're talking about theorems. In this case, it's not IVT, but yes, it will be MVT, mean value theorem. MVT is good. Okay, so why MVT? What can we do? What can we use the table for to help us prove why the MVT works here? Yes, exactly. So secant line slope equals tangent line slope at least 1 point. That's true. So if we want to prove that h prime of t equals 2, what can we use the table to show? How can the table help us prove that? Yeah, good. Okay, so the rate of change over 3 to 5. If you take h of 5 minus h of 3 over 5 minus 3, you end up with 2. Okay. Here, let's look at the rubrics so you guys can see. Okay, so if you look at part B here, part B, it uses h of 5 and h of 3, the rate of change from 3 to 5, as Raya had said, and it finds that that's 2. Well, by the mean value theorem, since we know h is differentiable, h has to be continuous. And why is it important to state those two things in this answer? Why should you say h is differentiable and h is continuous? Good conditions for the mean value theorem. So if you don't write those requirements down, you won't be able to get full credit there. Okay, so h is differentiable on 3 to 5, h is continuous on 3 to 5. Awesome. Okay, so by the mean value theorem, since there's a place, 2 points, 5 and 3, where the average rate of change is 2, then h prime at some point has to also be 2 by the mean value theorem. Okay. Are there any questions on that part? Why do we use 3 and 5? We use 3 and 5 because when you take the average rate of change between them, you get 2. So you can use any 2 points in that table as long as when you take the average rate of change between them, you get 2. It needs to be 2 because it told us h prime of t had to be 2. Okay. Are you ready to try the trapezoidal sum? So if you use 5 and 7, so if you used 5 and 7, from part A, we used 5 and 7. You can see the answer up there for part A is 5 over 2. So no, part A, well, 5 and 7 wouldn't have worked because you wouldn't get 5 over 2 as your average rate of, or you wouldn't get 2 as your average rate of change. And since they want us to find when h prime of t is equal to 2, you need to find an average rate of change that has h prime of t equal to 2, or that has 2 as its answer. So we've got to use, if you can find another two numbers that when you take the average rate of change between them, you get 2, you can absolutely use those other two numbers as long as it's data from the table. But we can only use two numbers that have an answer of 2 when you take their average rate of change. Okay. Yes. Yeah, so there's no real shortcut unless you can look at the table and in your head say, oh, I know that between those numbers we'll get 2. There's no way of knowing when you have a table. You've just got to test until you find the one that works. Sometimes looking at the table can help. So let's look over here. Back at the table. So I know this is going to be a little bit blurry, but it's going to let me write on it. Okay, so let's look at this. I'll make it bigger for you. So if you look at the table, you've got 2 to 3, but the h of t only went up by 0.5. Okay, and then you've got 3 to 5 and 2 to 6. And from 3 to 5, you've gone up by 2. And from 2 to 6, you've gone up by 4. So automatically there, if you've got 4 and 2, 4 divided by 2 is going to give you 2. So it's kind of looking at the differences between the x's and the differences between the y's. And then dividing the y's by the x's will get you the one that you want. So there's some shortcut ways to kind of go around having to write every single one out. Okay, so we can talk about part C. Use a trapezoidal sum with 4 subintervals indicated by the data in the table to approximate the average height of the tree over the time interval 2 to 10. So in this case, do you guys know you haven't, okay, so trapezoidal sums should still be included on the exam. Trapezoidal sums are just like Riemann sums, except you're making trapezoids instead of Riemann sums. So, or instead of rectangles. So does anyone remember the formula for the area of a trapezoid? Okay, good. Okay, so Aparna, we can talk about that later. There's some videos already on Fiveable that you can already find about trapezoidal sums, and if not, we can do even more sessions on it. Okay, so let's see. We've got a few different setups. But the area of a trapezoid is going to be base 1 plus base 2, right, divided by 2. That gives you the two heights technically, because our trapezoids are on their side, times the height gives you the area. Okay, so I'm just going to draw this table out because that's probably going to make it a little bit easier for us to tell. So at 2, we're at just 1.5 here. At 3, we're at 2, so we haven't moved very much. So we've got a point here, a point here. At 5, we're up here at 6. Now this is just an estimate, just to help us draw out the trapezoids. At 7, we're at 11, and then at 10, we're at 15. So that's going to be really high up here, but we'll just put it right up here because that's really all we need. Okay, so notice it doesn't say 4 equal subintervals because based on what you're given in the table, it can't be 4 equal subintervals. Okay, all that you do when you're making a trapezoid is you're actually using the y values, the 2 longer sides, as what's considered base 1 and base 2. And this right here in between them represents your height. Okay, so this is our first trapezoid, base 1, base 2 in height. And then here's another one. Here's another one. Again, these are our heights. And another one. Okay, so from 2 to 5, or sorry, that's 3. So from 2 to 3, we have a height of 1. And then we have to multiply that by base 1, which is 1.5, plus base 2, which is 2, over 2. And then that gives us just the area of this one right here. So we've got to do that for each of them. So then 3 to 5 is going to be 2. And then we've got 2 plus 6 over 2. And then we've got 5 to 7, which is another 2. And we've got 6 plus 11 over 2. And then we've got our last one, 7 to 10 is 3. 11 plus 15 over 2. And that would give you the trapezoidal sum for that one, which at the end comes out to be 263 over 32. I don't think I really want to take the time in this video to have to go over that. So in this case, though, something about this problem actually is no longer on the test. So let's talk about that for a second. If we go back to this question. This is a no calculator question, yes. So any question, if you're going back to look at old free response questions, because those are actually available to you. If you research AP Calc AB or BC free response questions, you'll be able to see all of the past free response questions and their answers. Questions 1 and 2 are calculator questions, and questions 3, 4, 5, 6 are no calculator. So since this is question 4, we know it's no calculator. And let's look again at the free response question. It says use a trapezoidal sum with four subintervals indicated by the data in the table to approximate the average height of the tree. Okay, so average height, some of you may have already learned average value. Has anyone learned average value? Yes, okay. So average value, still good to know and still will help you next year, but average value is part of Unit 8, so average value will no longer be on the test. You still need to know how to use the trapezoidal sum. You still might be asked to use a trapezoidal sum for just a value, but it won't be an average, okay? So what we actually did, what I did with you on paper was not average. It was just the regular trapezoidal sum over a period of time. Okay, are we good with this question? Question 4. Yeah, so the average, for the average, you would then take the difference between A and B and you would divide by that difference. So we would take that trapezoidal sum we found and we divide it by 8 because that's the difference between 2 and 10. That would be our average value. Okay. Okay. So just to go over, I've got a few questions here on arc length, actually not arc length, but cross sections and disc and washer method. Those ones will not be on the test. So those we definitely will still go over. I'm happy to go over them. I don't think we're going to have time today in this hour session, but we will be having a ton of these sessions, especially because it seems like you guys have a lot of questions that you're ready to ask. So if your question hasn't gotten answered yet and there might not be time to answer it today, don't worry. We will get to it in future streams, and doing problems like this is going to help you anyway, doing out these free response questions. Okay, so the next topic that everyone has voted up is optimization. Do you guys have any specific questions you want to ask? Because that's definitely a general topic. Are you most concerned with relative max or min, absolute max or min? What kind of optimization problem would you like to go over? You want to go over an applied problem where we're using like a scenario? Okay. Okay. All right, let's go over a problem. Let me share my other screen. Okay, absolute versus relative max or min. In absolute max or min, you have to also test the endpoints to make sure. So on relative max or min, you find all of the critical points, which is all the places the derivative equals 0. And you test those, you plug them into the function to see which one gives you the highest value and the lowest value, and you found your relative max or min. But when you're talking absolute, besides those critical points, you still have to test the endpoints too, because there's a chance that even if the max is here, the endpoint could be way up here. So absolute max or min, you have to make sure you're testing the very ends of the graph as well. Okay. All right, so let's talk about optimization. Okay, let's say we've got a rectangular field here, and it's going to be bounded by a fence on 3 sides. Let me not forget to make this bigger for you guys. So this is fence, this is fence, fence, and this is our field in here. Okay. And on the 4th side, we've got a stream. Okay, so over here, we've got water over here on the 4th side. That's bounded it. So we don't need to worry about fencing it on that side. All right. Find the dimensions of the field with the maximum area. So maximum area. But you want to find the dimensions. That can be enclosed using 1,000 feet of fence. So what's the largest area we can enclose with 1,000 feet of fence? How do we want to start this? Okay, 2 equations. Good. What would our 2 equations be? Area equals x times y. Good. And perimeter. Yes, perimeter would be good too because we have 1,000 feet of fence. It's not the exact perimeter, but yes, Joey, good. So we've got 1,000 equals 2x plus y. So oftentimes with optimization, you end up needing 2 formulas. That's a really good way to put it. Joey, what you wrote there. You're looking for 2 different ways that you can relate it. So what do we then want to do with those 2 formulas? Okay, good. Both good. Plug one into the other, take the derivative. Okay, so let's start with plugging one into the other so that we can get each equation to have one. Oh, to have one. Don't they have names? What do you mean by names? This is our area formula right here. This is our perimeter. And based on how we wrote perimeter, this side is x, and this side is going to be y. Okay. Oh, I've never called them by different names. But since we're looking for max area, that's the one we're going to be working with more, and this is the one that's used to plug in. We could call them primary and secondary, whatever you would like. Okay, great. I never called them that, but that's good to know. Thank you for teaching me something too. Okay, so what we're going to do is we're going to take our perimeter formula here, and what do you want to solve for? What would be the easiest thing to solve for? I would say probably y, since it's already alone. Great, awesome. Minus 2x, minus 2x. We get that y equals 1,000 minus 2x, and then we plug that into our primary equation. So a equals x times 1,000 minus 2x. Good. And why did that help us? Why did rewriting it like that help us to be able to solve this problem? Exactly. We were going to have to do implicit differentiation. We probably wouldn't have been able to get to the answer, or it would have been a lot more complicated to get there. So since we've only got one variable now, we can take the derivative a lot easier. All right. So we've got this. Let's simplify this to be negative 2x squared plus 1,000x. And we want to take the derivative of that. Yes? So we've got negative 4x plus 1,000. Are we good with that? Awesome. So how does that help us? How does having that derivative help us? Good. Joey, we're going to set it equal to 0. Negative 4x plus 1,000 has to be equal to 0. Why does the derivative have to equal 0? Well, because if we can find when the derivative is 0, so if we find where dA dx equals 0, that's going to be a max or a min, some kind of turning point on A, right? It's going to give us our max. Good. Okay. Awesome. So minus 1,000. X equals 250. Yes, good. Okay. So now here's the problem here is that this is an absolute max or min problem. So we need to make sure we know what our endpoints are. How do we know what is the range of values that X is going to be between? It's our domain here. So we want to kind of think in the context of the problem. What is the very smallest X could be? Good, Joey. So 0. It can't be 0. It could be 0. That would mean that it was just Y. It was just a straight line. We'd just have a fence and we'd have our water on the other side, but then we wouldn't have a closed-in area. Okay. So that actually probably means we don't want this or equal to sign under here. We just want less than 0. Okay. Now, and then less than or equal to, I'm going to agree with Joey on the 500 as opposed to 1,000. Why is 500 the largest X could be instead of 1,000? Then it would be a square because of 2x. Okay, so I was going, Joey, I get what you're saying. I was going with what Rita was thinking. We've got 2 X's on the problem. Yeah, because of the second equation, if you plug in 0 for y, X has to be 500. That's the biggest we can get. So now we've got these 3 points here. We've got X equals 0, X equals 250, and X equals 500. And to do this problem completely out, you need to test each of these points in your original problem. Okay, so what's our original problem that we're testing this on? Well, I think the best thing to go back to would be our new area formula, which was negative 2x squared plus 1,000x. So what's going to happen if X is 0 is the area is going to be 0. So that doesn't help us at all. Okay. And what about if X is 500? What's our area? Well, we've got -2, 500 squared minus 100. Sorry, this should be 1,000. 1,000 times 500. Yes, this should also give us 0, because if area is x times y, and you make x, which in this problem would be 1,000, y would have to be 0. Okay, so in both cases, area is going to give us 0. So I'm pretty confident that neither of those are our maximum area, since hopefully our maximum area with 1,000 feet of fencing would have to be greater than 0. So then how we find 250 is we just want to plug that in. So we get -2 times 250 squared plus 1,000 times 250. Has anyone done that out? I haven't gotten to do that out yet. Can get my calculator. Okay, I got area equals 125,000. Okay, so that's definitely our maximum area. One thing we want to go back, though, and look at is what was this question asking for? Okay, so if we go back to the beginning, it said to find the dimensions of the max area. Yes, good. Okay, so if we know we want the dimensions, we found that x is 250. So what does y have to be? How can we find y? 500. Good. How did you find that? If it doesn't pop into your head right away, yeah, you could do that, Hannah. Or you could use the perimeter equation. Good. So if we look back at our perimeter equation, it's 1,000 equals 2x plus y. So 1,000 equals 2 times 250 plus y. And now we see here that y is going to have to be 500. Okay, so for optimization problems, what are some main points here? We're going to have two equations. That's going to be a primary and a secondary. Okay, and then you're going to use the secondary, solve for one variable, and plug into y, and plug into other primary equation. We'll say that. Okay, and then from there, we take the derivative of the primary and we set it equal to 0. And then we test. Those are going to be our critical points. Whatever points come out of this are our critical points and endpoints. Okay, and then last but not least, you need to make sure you're finding the answer they're looking for. So look back to see exactly what you need to find. Can you use any equation in the solution to get x and y and a to get y? I'm not sure I totally understand the question. Could you reword that? Oh, so like, could we use a equals x times y instead of using, yes, you could use both of those. Because you'd say, we'd find the area, which was this, that was our max area, equals 250 times y. You could divide by 250, and you'll get y is 500. Joey, what do you mean by that? Sometimes y isn't always just y. There will be different equations where you might have to solve for more information in order to get it, but you should be able to plug it into either equation as long as you have all the other information you need besides what you're looking for. Right, good. Okay, so that's what I thought you meant. So sometimes you might have to do more steps to solve for y, and that's okay. But as long as you know what area is or what perimeter is, and you can plug in every other variable besides the one you're solving for, then you can solve for that variable. Okay, so we're at an hour. I didn't get to answer all of your questions. I'm excited that you all came with questions. I was worried that you weren't going to have any, and I was just going to be babbling on to you about different types of math. And so I have more information in a PowerPoint that we can save for another one. As for your questions, I'm going to take this back to Fiveable, and we're going to make some streams based on what you've asked about. To make sure that we can cover everything you've asked. And so make sure you're looking most calculus streams, all of them as of now, but we'll see what we need. Most calculus streams will be on Mondays around this time or at 9 p.m. I'm actually doing another stream tonight on how to interpret a derivative or an integral. So like the problem we did today where it said interpret what h prime of 6 means in the context of the problem. At 9 p.m. I'll be doing a stream on that that you're welcome to come and ask questions at. We went over related rates and optimization today. Yes, so College Board is for AB is going to leave out Unit 8, and for BC is leaving out Units 9 and 10, except they're including Units 10 for 10.2, 5, 7, 8, and 11. If you go to AP Central, there's a page that says get updates on what's going on with COVID-19. And if you click on that, you can, I think, see the sections that they're leaving out. So just to review again, the test is going to be at home on your computer. And again, College Board, obviously all of you have internet right now because you're on this with me, but College Board has said that if you have trouble with internet to contact them, and they should be able to get you a place where you can take the test. Right, thank you for sharing that. That's exactly what we need. And so the test will be, we don't know the setup yet. Next things will be April 3rd. Since we didn't cover Unit 8, will that affect you when you go to BC? It shouldn't affect you. You either should learn it even after the test. Your teacher might continue teaching because you need it for BC, or you can use Fiveable to learn it, or you're going to go over it again in BC. This isn't just happening to you, right? This is happening to everyone across the country, across the world. So there's going to be a lot of expectation changes for next year for how do teachers in general go and help get students caught up if they had missed anything. So College Board has said that colleges are still just as willing to accept the students and the scores. The thing that you have that can be helpful to think about is that the way that the AP is scored is on a curve. So a 5 on the AP exam is based on a certain percentage of students getting that high of a score. So in this case, it might just be that you need to get a higher score in order to get a 5 if the test ends up being easier in some way because there's less information on it. It really depends, but again, since everyone's going through it right now, everyone that's applying to college and everyone that's taking this test is going through the same thing. You guys are all being considered on that same level. So it shouldn't affect how your score goes to a college. College Board has checked with colleges to make sure they will still accept it. So if you get a 5 or a 4 on this test, then you should be good to get acceptance to college. A 3 at most colleges as well is good. So yes, they should still accept your scores. A long version of that answer. Any other quick questions on the setup? Okay, so for now, I'm going to log off. But again, I'm sorry if your question didn't get answered. We'll have so many more streams for you guys. We're so happy to be able to help you in this time. I'm glad this was helpful. Feel free to leave any comments or let me know if you need anything else. And if you have more questions, please leave them in the question box so that we know exactly what you want streams on. It was great getting to talk to you all. Thank you all for participating. I'm glad that you found this helpful, and I'll work through some of those blurry pictures for next time to make sure we've got it nice and clear for you. Thank you guys. Have a great day.